So hello everybody, here's part two. Outside in the garden today, as you can see it's a lovely day, and obviously as you can see I'm feeling a lot better. Thanks everybody for the lovely messages that you've sent, wishing me well, and we're all doing all right now. We've got a couple of snotty kids, but nothing too severe. So today we're just going to talk a little bit about coronavirus and understanding the enemy. So I'll talk you through what a coronavirus is, how they work, and really what makes you get ill when you've got one, and why some people get more ill than others. Okay, so oh, hello. What have you got there? What's that? Have you drawn coronavirus?
Yes, the coronaviruses, and the coronavirus can make copies of itself in your body, and if you spin the garden, you or in any place you go, if you spit in any place anywhere you go,
Yeah. What happens?
you might have the virus, and the virus might go in the saliva and
In the saliva, yeah.
in the saliva and it might go into people's bodies.
Yeah. What do we call that? We say that they might get in. Do you remember? Infected.
Infected.
Okay, so we have to look after other people, don't we?
We have to
By
look
doing the
after-
right things ourselves, yeah?
Yeah.
Okay. All right, let me carry on then, okay? Thank you. Bye-bye. So the coronavirus, it's from a family of viruses. There are 7 known strains. 3 of them are bad ones. And the rest of them, the other 4, just give us like the common cold, so we get them all the time. So the 3 bad ones that we know of are MERS, MERS, which is Middle Eastern, or causes Middle Eastern respiratory syndrome. SARS, which is causes severe acute respiratory system, which means it gives you pretty nasty pneumonia quite quickly. And the one that's currently knocking about, which has got us all locked in our houses, which is called SARS CoV, CoV 2. Okay, so that's coronavirus as we're calling it. The previous one was called SARS Classic, and they're all RNA viruses, which means that they don't have DNA. They have something similar to DNA, which is called RNA, and that's what they basically inject into your cells. And use your cells' mechanisms to make copies of themselves. So coronavirus is called coronavirus because the virus particles themselves are circular, and they have little spikes, little protein spikes coming off them. So they look a bit like a crown, or a bit like a solar corona. So solar corona is like when you draw a typical sun and you draw the rays coming off the sun, the rays that you draw coming off of the solar corona. So that's why it's called a coronavirus, because it looks pretty much like a crown. Those spiky bits are the proteins, and that's what the virus uses to bind, to attach to your cells. And then through that mechanism, your cell itself then opens the virus particle, and the virus puts its DNA, basically its gene, or its RNA rather, into your cells. So what do we know about it? Well, first of all, we know it's really contagious. We know that it survives for various periods of time, hours and days, in different materials outside the body. But really, as a virus, it needs to reproduce, and in order to do that, it needs your body cells. It can't reproduce outside of your body cells. So this coronavirus, this strain of coronavirus, has been really successful. It's been super contagious because about 85% of people who get infected with it seem to have very mild symptoms. So a bit similar to the kind of symptoms that I had. A bit of a cold, cough, those kind of things. Nothing major. Something that, the kind of symptoms that you might normally consider continuing on with your normal life and not staying at home. And some people have no symptoms at all. So if you think 85% of people who get infected with it don't really know they've got it, or might not suspect they've got it, because they might expect to be more ill than they actually are. So that means it's easy to pass on. And unlike the previous versions, MERS and SARS, it doesn't make people ill enough to stop their daily lives in most cases. So that means that people are out and about and they're spreading the virus around, so it's making it highly contagious. So the government's advice has been mainly, wash your hands. Okay, wash your hands, wash your hands, wash your hands. Well, the reason for that is because the viral envelope, basically the bit that keeps the RNA inside the virus, is just made of lipids, fats. So with simple detergent, soap, and hot water, you can disrupt that. You can break that little membrane, which is like the membranes that make our cells, that keep our cells intact. Can break it open and therefore destroy the virus. So washing hands is quite an effective way of stopping this virus. And as it is with most viruses, respiratory viruses that infect your cells in the respiratory tract. Okay. In terms of infection, how does it work? So within your respiratory tract, you have on your cells some receptors, and it seems that this coronavirus prefers specific receptors, which are called ACE2 receptors, or ACE2 receptors. And you have them in most of the cells throughout your respiratory tract. So that means that the virus could bind to any of those cells and therefore enter in those cells and cause an infection in those cells. So if you're lucky, somebody like me, okay, and you get an infection in the upper respiratory tract, so sort of in this area, not too severe, gives you some relatively mild symptoms. If you're unlucky, that virus can then, or that infection can then pass deeper into the lung tissue, right in the bottom, where all the gas exchange happens in the alveoli of your lungs. And when that happens, that's really severe and causes pneumonia. So how does the virus actually infect the cells? So it binds to these ACE2 receptors, which we'll talk a little bit more about later on. And when it does that, the cell itself that it's binding to produces an enzyme, and that breaks open the virus and allows the virus to put its RNA, its genetic information, into the cell. There's two possible mechanisms the way that it does that. It either splits it open and allows the cell to inject that genetic material, that RNA, or the cell sort of engulfs, a bit like in phagocytosis, right? Endocytosis. It engulfs that genetic material and takes it in as part of its membrane. Okay. Once the viral genetic information is inside the cell, it then uses the cell's ribosomes to make copies of itself and make lots and lots and lots of more virus particles, and those new virus particles are wrapped up in little vesicles, little membrane-bound packs inside the cell, and then they're released outside the cell by a process called exocytosis. Okay. So let's go back to the receptors, and this is a bit of the reason why some people get more ill than others with this virus. Some people have got more receptors than others. So, for example, it seems that males have more ACE2 receptors than females, and in general, males are being infected and having more severe disease with this virus than females. In young people, it seems that there's possibly less ACE2 receptors being made when you're young. So that's another factor to add in and to the equation as to why children seem to have less severe disease than older people. And of course, another factor here is that as you get older, your immune system doesn't work quite as well, so it can't produce antibodies to this virus quite as well as when you're young, and your immune system's working a little bit better. In terms of age as well, what can happen as you get older is that your immune system can overreact. It can go a little bit crazy. It's called a cytokine storm, and it can overreact, and when it does that, it can cause even more severe disease in you. and it seems that doesn't really happen in younger children. So these cells, once they get infected in your airways, they die, and they get washed down further into your respiratory system. If you're unlucky, that causes the virus to get washed further down, deeper into your lungs, and causing more infection in the cells deeper down in the lungs. And what those dead cells and your body's response to those dead cells can cause is for your lungs to start to fill up with fluid. Okay, it sounds, like it's not like a bath full of fluid in your lungs, but little bits of fluid, and that obviously means that you've got less surface area in your alveoli available for oxygen to diffuse in and carbon dioxide to diffuse out. So difficulty breathing, difficulty doing respiration, which we know is not breathing, if you remember, and therefore severe illness and possibly death as a result of that. Okay, but luckily, as I said before, 85% of people who get infected with it won't have those sort of difficulties. Okay, so that's pretty much what we know so far, and interesting to see that the government's now going to bring out more testing, going to improve their testing regime. So we'll be able to find out a bit more about who's got it and who's recovering from it, and that will add to and improve the fight against this virus. But for now, keep doing what you're doing, stay at home, get bored, and then find a way out of your boredom, learn a new skill, enjoy the people around you, enjoy this beautiful sunny day if you can get outside, and speak to you again soon. Okay, bye.